Geometry, Unit 4, Lesson 10. I can solve for unknown sides of 30, 60, 90 triangles using special right triangles. So this is special right triangles continued. We already talked about a 45, 45, 90 triangle. Now we're going to talk about a 30, 60, 90. And let's go ahead and do this little investigation. Our side lengths are going to be 2. And if it's equilateral, then we also know it's equiangular, don't we? So you can go ahead and go in there and say that these are going to be 60, 60, 60. Now, I want the midpoint of AB. Okay, I'll make the midpoint right there. And I'm going to call that D. And I want to sketch a perpendicular bisector. Okay. There we go. It's perpendicular. And it'll bisect this and this. Now if this whole thing is 2, then you know this and this must be 1 each. And the other thing is, if it bisects angle C up here as well, if the whole thing was 60, now this bit right here is just 30, and this bit here is 32. So now you can see where the 30, 60, 90 triangle came from. It came from a regular triangle. All the sides were the same, all the angles were the same, but we bisected this angle and this side, and that's why it went from 60 to 30 and from 2 to 1. So this relationship, if you take a look how this little side here, if you double it, you get this. It's because they were the same length, right? We're only going to look at half now. So I'm going to go ahead and resketch this below really quickly. Here's my 30, here's my 60, here's my 90. Look where it came from. And all the sides used to be 2, except this now is 1. Question is, what's this side? So if I were to ask you, where does a 30, 60, 90 triangle come from? You would say, well, it came from a regular triangle. We're just taking half of it. Used to be 60, 60, 60. Now it's just 30, 60, 90. Used to be 2, 2, 2. Now it's 2 and 1 because we took half, right? Half of this right here. So let's go ahead and what kind of triangle do we have? We already said it. 30, 60, 90. And we want to now find this missing leg. Now this is the dangerous part. Always do that annotation to find your longest side, C. There's the hypotenuse. So now, when you go ahead and do a squared plus b squared equals c squared, you're going to make sure you put the sides in the right places. There's your 2 right here. That's the c. Don't put 2 and 1 right here. That's wrong. This b that I'm looking for is right over here. And so now I'm going to take away 1 from both sides. And I end up with b squared equals 3. And I'll square root both sides. B is equal to square root of 3. And is there a number in front of that? Sure. It's a 1. Here we go, 1 square root of 3. Okay, why don't you hit pause in just a moment and try it again yourself right here, but let's make our sides not be 2, 2, and 2, but let's make it 10, 10, 10. Why don't you do the same process, hitting pause. Okay, here I go. We're going to have 10, 10, 10, and we had 60, 60, 60. I'm going to drop a perpendicular bisector in. So, and this was the midpoint right there. That was point D. So if we do that, we now have 30, 60, and 90. And this was 10. And while this whole thing here used to be 10, I lost half of it. So now this is just 5. Question is, what goes there? Go ahead, do the Pythagorean theorem. So we'll put 10 here, 5 here. So now we have to do square root of 75, and that's 25 times 3. So square root of 25 times square root of 3. I know this is 5, and that's just square root of 3. So if we go back over here, you've got 5 square root of 3. The hard part now is, can you see a pattern? And if you look really closely, you'll notice whatever is opposite the 30, if you shoot across from that 30 degrees, that's the smallest side. Whatever that is, if you double it, it goes here. And over here, you just write it with a square root of 3. And if we go back and look at it in both places, that is what happens. So here, whatever is opposite the 30, okay, is the side length 1, doubled is 2, and over here, there it is, 1, but just with a square root of 3. So whatever's here goes here with a square root of 3, whatever's there goes there with a square root of 3. The hard part is remembering what goes where. The key is to definitely find the 30. You have to find the 30, and if you go across from the 30, that's where your x goes. Let me show you what I mean. If we come down here, the first thing you want to do is find the 30 degrees, and if you come across from it, that's your x. And then this is going to be your 2x. And this is going to be your x, but with a square root of 3. Why is all of this? Again, remember, I could sketch in the rest of the regular triangle. Whatever this was, it was right here, but I have half of it now. That's why if you double this, you get the full side over here. And based on Pythagorean theorem multiple times, whatever is across from the 30 goes right here with a square root of 3, which is across from the 60. Very tricky. Start with across from the 30, that's your x. And you should be able to know that the longest side over there is double that shortest side, leaving the other one as the x squared root of 3. Let's go try some really quick to see how you feel. We're going to go back to our ghost triangles. Our goal is to find all the missing sides. Here's my ghost triangle, sketched the same way as that. So I'm going to go ahead and write in 30, 60, and 90. And for me, I know coming across from the 30 is x. This is going to be 2x, double that shortest side. And this is that other thing, x squared root of 3. How do you remember it's square root of 3? I remember there's 3 different angles. So there's 3 different sides and the square root of 3. When it was 45, 45, 90, I had only 2 different kinds of angles, 45s and the 90. That's why that one was going to be square root of 2. That's how I remember it. Anyway, let's go ahead. Across from the 30, okay, this 4 right here equals that x right there. So these guys are equal. You can go ahead and write it out. So 4 is equal to x. So if this is 4, wherever I see an x over here, I have to put a 4. Okay, because these guys are equal. So I'm going to put a 4 here, but with a square root of 3 next to it. I'm going to put a 4 right here, but times 2. There we are. Those are the missing sides. You can go ahead and hit pause, try it on your own. Okay, here I go. That's the 60, which means this would have to be 30 if all 3 interior angles are going to sum to 180. Okay, across from the 30. It's my x. Here's the longest side. That's going to be 2x, and this will be x squared root of 3. Just sketch a bunch of ghost triangles if you have to. Okay, that's kind of my x. This will be my 2x. This is x squared root of 3. Well, 2x, this is what they gave me, and it equals 2x. So these are the guys that are equal, 14 and 2x. So 14 equals 2x, divide both sides by 2, x is equal to 7. So this was 2 times 7 to get 14. So wherever you see an x, it's 7. So this is going to be 7 right there. And this is going to be 7 as well, but next to a square root of 3. Okay, those are the basic ones. Here comes the advanced, or rather the proficient. So I'm going to sketch my ghost triangle, because I don't see one. These must be my 30s. And now, start the same way every time. Across from the 30 is your x. Across from the hypotenuse will be double 2x. This will be x squared of 3. So here's your x. This whole thing is x. So when you go to write it here for 2x, okay, when you put this whole thing right here in for that x, then you have to multiply it by 2. So it becomes 2 times 2 square root of 5. All I did was put this right there. That's going to be 4 square root of 5. You're going to put this over here, but it's x square root of 3. So just put this right there for the x. If I do that, here's 2 square root of 5. Go ahead and multiply. It's going to be 2 square root 15. There we have it. Try the last one on your own. Hit pause. Okay, here I go. Ghost triangle. Look how I keep moving that 30 on you. Be careful. That's your x. That's your 2x. That's x squared of 3. So let's see what we have. This is particularly challenging. That over there is your x. Look what they gave you. They gave you this 8. And that matches up here, over here to x squared of 3. This is the trickiest version. What do you need to do? Well, x square root of 3 is equal to 8. Let's go ahead and solve for x by undoing the multiplication with division. That turns into 1, leaving 8 over square root of 3, but you're not done. You need to rationalize the denominator by multiplying by 1, and in this case by square root of 3 over square root of 3. It's whatever that is. So we've got x is equal to 8 square root of 3 over square root of 9, 8 square root of 3 over 3. And I can't reduce that, so I'm done. That is your x. So as crazy as it seems, this whole thing goes right there. So this will be 8 square root of 3 over 3. Now, how do you find this side? Well, it's whatever x is, but with a square root of 3 next to it. This whole thing is x, right here. So I'm going to put it right there. Here I go. 8 square root of 3 over 3 times square root of 3. This is the x. That square root of 3 was already there. If you go ahead and multiply straight across, you're going to get 8 square root of 9 over 3. Square root of 9 is really 3. The 3's go. And you're left with just 8. Something went wrong. Because these both can't be the same. What did I do wrong? Let's find out. 8 square root of 3 over 3 sounds pretty good. If I put that right there, square root of 3 times square root of 3, that's just going to be a 3. Oh, it should come out to be an 8. I must have messed up down here somewhere. X equals 8 square root of 3 times square root of 3 over 3, so that's 8 square root of 3 over that. 8 square root of 3 over 3. Looks pretty good. 8 square root of 3 over 3 goes right there for x. Then what am I doing wrong? Aha! I see what I did wrong. I actually labeled these wrong. Looks, I put x squared root of 3 here, but that's the 2x. Hopefully someone saw that a little while ago. Boy, did I make a mistake. Forgive me. There you go. No one's perfect. This should have been the 8 square root of 3. Hold on a second. Oh, this whole thing has failed. Epic, epic fail. X square root of 3, so that's that. Ah, it's double. Whew. Okay, I got it. There it is, 8 square root of 3. This is just double. Look, it's 2x. 2 times whatever x is. In this case, it's this junk. 8 square root of 3 over 3. Thank goodness. And 2 times 8 is 16. So my final answer is going to be 16 square root of 3 over 3. Yikes. It was staring at me the whole time. It was just 2x this side right here. Take this, put it here, and times 2. Sorry about that. Definitely follow that ghost triangle. As soon as I ignored it, I ran into trouble. Good luck.